Hello all, this is TK from codewithtk.net. Today's session we are going to discuss about functions. Okay, let me open a new Jupyter notebook. I'm clicking on new, Python 3. Let me rename it to functions. Yeah. So what is functions? So functions are basically, you could say it's a kind of verb. Let's say do any task repetitively, say eating, running. Functions are also used to separate out your code, so which you need to call repetitively. Let's say you need to do some print before and after of doing something. All this kind of doing repetitive work, you can define a function and call the function. So I'll just explain what do I mean by that. So to give you a simple example, let's say I want to print hi, simple hi. And this is how we define a function. Just type def for defining a function. Let's say print hi is my function name. Okay, then use a colon to write down the actual code inside the function. Now all I'm doing is print hi. Okay, now in order to call this function, all I have to do, I have to just type this function name, print hi. Okay, open and close parenthesis. Now this is what it's doing. Now let's say I want to define a function called run. Okay, I just do def run, open and close parenthesis, semicolon, and say print I am running. Okay, let me call run. You see, it says I am running. Let's say similarly I want to define eat. Okay, now I'm just doing print I am eating. Okay, now call eat I am eating. Okay, now let's try to understand something called argument. So in open and close parentheses, inside this I can pass any value, and that is called the argument. So let me give you an example. Let's say I'm defining a function called greet, and then I'm just passing name with the greet function, and then all I'm doing, I'm just printing hello name. Okay, so print hello, then you can use plus name. Okay, so now if I call greet with my name, so it's printing this. Okay, it's just greeting the person. So this is how you can pass the argument. Now let's take few more examples. Suppose I want to square a number. Okay, so I'm just defining a function called square, and I'm just passing the number num. Okay, and you know that in order to square the number, all you can do, you can just multiply the number with itself. Let's say I say number multiplied by number, that should work. Then if I say 5, it works. Alternatively, you can do square is actually power. So syntax for power is 2 star, and square is the number to the power 2. Okay, so that also works. If I give square 5, it's 25, 6, 36. Yeah, that's how we can do it. Let's say I want to calculate the area of a circle. I want to define a function called cal area circle. Okay, now I'm just passing the radius r. Okay, and the formula for area of a circle is return. Okay, by the way, the return command is used to return the value. Okay, return the value back to the caller. As you can see, square 6 is returning me 36. Unlike our previous functions where I was just printing the value, here return means it will return the value back to the caller. I'm just trying to return say pi value. I'm just taking it as 3.14 multiplied by radius r square 2. Okay, so if I just do calculate area of a circle with radius 5, this is the value. Now we can have many arguments, not just one argument. So if you want to keep more arguments, you can use its comma separated value. Let's say I want to define a new function called add. Okay, define add. In order to add this to number, I have to just return number 1 plus number 2. Okay, so if I'm just calling this function add number 1 3. Okay, now let's say I want to define a function called multiply. Okay, define multiply number 1, number 2. Now I want to return number 1 multiplied by number 2. Now if I call multiply 4 and 6, okay, it's multiplying. Now there is another thing, it's called the keyword arguments. So instead of calling multiply 4 and 6, also what we can do it like this: multiply, say num1 is equal to 5. Okay, let me do the same thing. Num2 is equal to 6, and if you do that, I'm getting the same results, but I'm just passing explicitly the value of it. The advantage for that is you can change the order. Let's say I want to change it to number 2. Number 2 is equal to 6 and number 1 is equal to 4. So basically I can use in any order. That also gives me the same results. So that's the advantage of keyword arguments. Now there is also something called default value. Okay, I'm gonna repeat this function with a default value. Let's say I want to multiply two numbers, but with a default value of number 1 is equal to 2, let's say, and number 2 is equal to 5. Okay, so that's the default value. So in this case, what will happen is I can just call the multiply function without passing any value, because it has a default value. It's 2 and 5. That's why it's giving me 10. Now I have a lot of flexibility in this case. If I choose, I can pass only one value. Let's say I want to pass only one value, 3. What would happen? It will take the first value as 3 and the second value default is 5. So I expect it should return me 15. Yeah, it did. Now let's say I want to pass only number 2. What we can do is I can call multiply, then number 2 is equal to say 6. Okay, now this is return me 12 is because the number 2 value is 6 and number 1 value is 2. Now this way, I get a huge flexibility in terms of the passing the argument and having the default value. There could be certain situations, the most of often the default value is something, and you can make use of this feature, default value feature. So yeah, now let's say I want to just extend this function. Let's say I want to modify. I really don't know. I don't have only two numbers. I may have any numbers. Okay, I may have 3, 4, 5. I really don't know how many numbers I have, but I want to still add them, okay, or multiply them. So what I would do, I'll create a new function called multiply. I'd say multiply many. Okay, so here instead of passing individual arguments, what I can do it like that. I can just say args. Okay, so that can contain just star and args. That can contain any value, okay, any number of arguments. So what you can do is so in order to do multiply that, let's say I create a variable called m. Then I know there are many arguments and I don't know how many arguments, so I'm just running a loop over it. I'll say for num in args, what I want to do, m is equal to m multiplied by this number, okay, and then I return this m, the multiply value. Okay, let's see how it works. Let's say now we say multiply many. Here I'm passing 1, 2, 3, 5, 6, 7, any numbers. args, sorry about that. Okay, now say it has multiplied all the numbers together. So I have extreme flexibility. I can pass 2, 3, 4 on any numbers of item. Okay, so it will just multiply. I can even pass just one number, so it will multiply with 1. So that will give me the same number. Okay, so this is flexible. This is how we can make use of this args or args argument. Now let's say I want to make use of this. Now this is just with the single arguments. You can also use keyword arguments. with something called double star args. So what do I mean by this? Let me define another function. It's called print name. Okay, I'm defining one function, and here instead of single args I'm just giving double star args. Okay, so what is the difference here is, here I can have keywords, I can access keywords. So let's say this args contains two values. One is called first name, another one is called last name, and I want to print the first name and last name. The way I can do it is, I can just type print my name is, let's say I want to print comma args, then in bracket, this is what is the keyword coming from, f name. So that means arguments whose keyword is f name. I'm just trying to access that value. Then I want to add a space between first name and last name. Then I want to access args last name, and yeah, that's it. So now if I use this function print name, and in the keyword argument, the way we have to do is first name is equal to two-star, and last name is equal to colon. Okay, now you see it's printing my name, but you have to be careful. Okay, you cannot use wrong keyword and then try to access it. If you do that, that will give me error. Instead of L underscore name, if I give just L name, okay, what would happen? You see there's an error. It's telling that okay, L underscore name is not found in this line. So yeah, you have to be very careful with that. But yeah, it works. Let's think of something called recursion. So what is recursion is, basically recursion is a function calling itself. What do I mean by that? You know, inside function, whenever we are defining a function, we are just adding some statements inside it, okay, or sequence of steps inside a function. So that sequence of steps can include calling itself. For example, you know, this is how I'm calling this function. Let's say multiply many. Okay, I'm just calling this function. That function actually, I can call this inside this function itself. So let me give you an example. Let's say I want to define a function called print number. Okay, I'm just passing a argument called num. Now what I can do is I can just print this number. Then I can also call the same function called print number. So instead of printing the number, I'm just printing number -1. Okay, I'm just passing the argument as number 1. So this function will call itself. Now if I run it, actually the function, it will keep calling itself continuously. It will create a huge recursive loop and it would fail. So you have to give a exit criteria. Let me show you what do I mean by this. You see, if I just run it, it will ultimately fail. You see, it is printing the number, but it's keep on running. Okay, and ultimately at the end of it, it has given an error that exceeded maximum depth. So I need to create an exit criteria for it. The way to do it, I write a loop condition. Okay, so if, let's say I want to print only if the number is positive. If the number greater than 0, then print num, else return. So this is my exit criteria. So basically I'm telling, just if the number is less than or equal to 0, return. So no need to call itself anymore. Otherwise, call itself 1 less than value. Okay, if I just run it now, okay, sorry, I think I didn't execute it. If I just run this now, you see it has printed until 1 and then it has exited. So yeah, recursion is very powerful, but you have to define the exit criteria at the beginning. Otherwise, you will end up having an error. So now let me give you another example with recursion. Let's say called factorial. Okay, def factorial. What is factorial? Factorial meaning, the definition of factorial is this. Let's say I ask for factorial of 5. Okay, so it is equal to factorial of 5 is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2. Okay, so this is the value of factorial 5. So factorial 5 should be 120. Now let's see if we can implement this factorial function with the help of recursion. Now what about factorial 1? Factorial 1 will be 1. Okay, because you can't go 1 is the minimum value. Okay, so and it's always positive. Now let's say I'm just defining a factorial function. Now I'm just first I have to give exit criteria, as I said. If num equal to 1, then I would say return 1. Otherwise return num multiplied by, we call this factorial because it's 5 and then 4. That means then this 4 is actually 5 minus 1. That means num minus 1. So I have said factorial num minus 1. Now if I call factorial 5, factorial 4, let's say it's 24. Factorial 5, 120. Factorial 10. So you get it. So this is how we can define a factorial. Not be complete without discussing a very important concept called lambda. So what is lambda? Lambda is like an anonymous function, or you could say is a dynamic function. So let's say you don't want to define a completely new functions, but you want to use the benefit of a function. So the way you can do it is like creating a lambda function. So what do I mean by that? Let's say I want to square a number. So I'm just creating a function like lambda x, then you use colon, then you use x star 2. That means x to the power 2. So you know, when we are defining a function, we define a def function, and then okay, you can think that this part is a definition of function and this part is the execution of what you want to do. So now if you want to do it, if I click this, you see it has created a function at some destination. So what you can do, you can assign this function to a variable. Let's say I have assigned this function as a variable. Now I can use this sq as if I'm using a function. Let's say I use sq, then function 5. So it gave me 25. Okay, if I try, it gave me 81. So it is doing the square, and it is exactly working as if there is a function called sq, but instead of defining it as a function, I have defined it as a lambda. If you really want, you can define it dynamically. What do I mean by that? Instead of creating a variable, let's say I am defining a function, okay, lambda, then cube it, okay, instead of squaring it. Okay, so this is my lambda function. Now I want to call it just right now itself without creating any function. So way I can do it, you know, this bracket is my function, then I create another bracket, and then I pass the value. So you know, 3 to the power 3 is cube, meaning to the power 3. 3 to the power 3 is 27. So if I just give 4, you know, it's become 24. So here I've just defined a function and I have immediately called it, and I don't have any variable or anything. Alternatively, what you could also do is you could define it like this, cube, then define the function just like that. Okay, and then you can call cube. So you get the same results. Okay, now let's say I want to create a function called grid, which you already have done last time. Okay, so what we can do is I create similar lambda function as grid equal to, I create a lambda x plus space plus, that should work. If I just do grid my name, okay, grid Tushar, see it's printing hi Tushar. So basically, instead of defining it as a function, I'm just defining it as a lambda function. let's compare this. Okay, if I just instead I could have done it another way. I could have done it is like that. Okay, x, then I say print I plus x. Okay, so this will also do the same thing. If I just call it greet again, if I just do greet abc. Okay, so it works. Now the reason I have used x is basically just I wanted to tell you this x could be anything. Okay, here usually the convention people use x when they're defining lambda, but it can be anything. Let's say I want to change it to abc instead of x. It should also work. Okay, now if you just use greet to say, it still works. So this name can be anything, but usually the convention is use x when we're defining x for variable when defining a lambda function. I think that's it for our today's session. Thanks for watching. If you like my video, please hit the like button and consider subscribing. Please also hit the bell icon so that anytime I upload a video, you get instant notification. Thanks for watching again.